recording, sir.
Okay, fine. Thank you. See, just for the Jiva, for your information, so every month we are doing an online webinar in a different topics. So last month we have started. So every month our teammates, team members, our colleagues will give some kind of different topics with the latest technology. So just we are going to have this is the data analytics kind of stuff. Today I'm going to present it. So the first one in the presentation, first slide, shifting pattern surface, a 360-degree exploration of data insights. Just in this particular session, we are going to do some kind of data analysis using some kind of AI model. It's a very basic AI model we are going to do with this particular using some demo. Okay. So first, I am going to present. So why we are in this particular session, we are taking one problem and we are going to give some kind of solution for that problem. So in the first one, I have some data sets. I have some data sets which will indicate a person is getting heart attack. Why a person is getting heart attack? I think you in the recent times you may aware that you are getting many news. A person is in young age is getting some heart attack. So that's the reason I have taken this as a problem. I am taking one data set. In that data set, we are coming to the solution to give a particular using some model. So first, why heart attack in young ages? So that is the problem. And how you're going to predict. So using the data set, how you are going to predict from the data set. So that is our thing. See, okay, why heart attack in young ages? We have a lot of problems. There may be a different parameters in the young ages. The people are getting heart attacks. So lifestyle changes. I think you know that lifestyle changes. Example: smoking, drinking, and that means a sex, that is male or female, and age criteria is one of the parameter. And the illness, that means comorbidities like a high blood pressure or diabetes or eating habits or obesity, and other health condition as well, anxiety, stress. Lot of things are, these are all some of the parameters associated to get heart attack in young ages or early ages. So how to predict using some kind of data set, how we are going to predict a person is getting heart attack or not in the early ages. Next. So in the data set, there are certain attributes which is available. So these are all the data set. Anyway, while going to the demo, I am going to give the data set in the CSV format. So these are all the attributes. From these attributes, we are going to have some kind of analysis using some AI model and get the using with the data set, a person is getting heart attack or not. So that is our outcome. Okay, so the attributes are age, sex, and chest pain type. They have given some 4 kind of chest pain type with 4 different values. Anyway, I'll show those values while doing that execution part. And trust BPS. That is, so in that you are getting a heart attack. There is a BPS value is there. So in the resting time, what is the BP value for a person? So that is one important criteria or important attribute while doing some analysis. And cholesterol, I think you know that. So cholesterol is very, very important factor a person is getting a heart attack. So cholesterol also has to be taken care. Then the sugar, already we have discussed. A person is having some kind of high blood pressure using some cholesterol or some sugar, that is diabetes. In that, if that is the case, a person has the fasting blood sugar. So those are all the values has to be taken care. Similarly for rest ECG and maximum heart rate and exercise include. See, in when you go for some kind of the first level of test is, I think you might have heard about ECG, electrocardiogram. That is a very basic test. Not for that, apart from that, we have other tests also, echo test is available, and treadmill test is available. A lot of things are there. So a person is having some kind of different issues, or if he is getting some kind of problem, the doctor will prescribe the subsequent tests. So you have to pass, and you have to pass those kind of tests. So these are all the values which is available, just old peak and slope. So the old peak and are all that I have mentioned in the right side. You can see that in the ECG you can see some kind of curve which will go up and down. You might have seen. So there are some kind of ST segment depression. Depression is there. There is some values there. I think in the second picture I have mentioned that unsloping, downsloping, horizontal. So different kind of that wave signal is there. That rhythm is there. Based upon the rhythm, they will take a person is having some kind of problem in the heart or something like that. So using that kind of analysis, they will do that. Finally you have the normal and fixed defect and reversible. So these kind of values which is available in the data set. Okay, so these are all some of the ML models. Here I am going to touch just a logistic regression model, a very basic model. So why we are taking a logistic regression model? See, in this particular category, anyway, I will deeply explain in the next slide. So why I am taking the logistic regression model is, a person is getting heart attack or not. Either a person is, that means the value of logistic regression model between 0 to 1. Either it is in a 0 state or 1 state, in between, like that. So within these two values, a person is having, one is a 0. 0 means a person is having heart attack, or one is not having the heart attack, like that. So there is the model. So there is one 0 or 1, either true or false, like that. So that's the reason we are taking as a logistic regression model. This is a very basic model. You can have other models also for the deeper analysis. Okay, so what we do, so we are doing some kind of in the left hand side you can see what we do and why we do. So what we do category is, we are just extracting from the data set. We are just pulling out the values from the data set. And the second one, we are analyzing. We are giving some conclusion. We are doing some analysis, how it is related with the relationship between the two values. Those kind of things we are going to see. So that is what we do. Why we do? Okay, so we are going to apply based upon some analysis. You are getting you are coming to the conclusion that a person is getting heart attack or not. So why we do? So find the best model, or find the best algorithm for this particular scenario, and prediction of severity of diseases in the early stages. So we are going to predict a person is getting heart attack or not. It's a very basic model. Okay, why Python? We have other technologies are available, other things are available, but in the machine learning part, why we are going for Python? So Python is a very popularly known and everybody is using around the world. So these are all four important things why. So libraries and frameworks, we have a lot of libraries. Just you have to include the library and execute. You can include the model, you can execute in a simple single word. That's it. Just add the library or add the framework. That's enough. And simple and consistent. Platform independent. Yes, you can run it anywhere in the platform. Different platforms you can run. Okay, great community base. This is an open source again. So many of the startups are using, because it is a open source, and we are getting the community base, and widely popularly many people are using. Suppose if you have any problems in the while doing some code clarity or code doubts, you can ask with the community. So that is, the community has developed this Python. So that is the main thing. Okay, why Python is so popular choice for data analysis? Easy to learn, versatile, powerful, open source, and large community. Okay, so here example application. So when we do some analysis, we are going to have the first important criteria is, we are just cleaning the data, because the data may be clumsy, the data may be not suitable for the execution process itself. So the first part, the first step, we have to clean up the data. So data may be raw data. The raw data may be some kind of clumsy, and you have to remove. You have to keep only the data which is required for your creating a model. So first of all, you have to clean that thing, and you have to manipulate if it is required, and visualization from that data, what kind of visualization you are going to make, and using some visualization, how you are going to be. So we are going to implement some kind of model or algorithm for that. Okay, basic Python libraries. So here in the Python, we are going to use in this particular demo only the pandas and NumPy. So there is pandas is nothing but we can say it is a pandas is a library which having a rows and columns. Suppose if you are playing with huge kind of data set, definitely you have to go with the pandas, because pandas is the one important aspect is that I think you might have seen in different languages array is a collection of similar data items. You might have heard about that. But in Python you have a pandas. It is also a collection of different data items with the rows and columns of with different formats. In this picture itself, we have mentioned, so you have ID, name, age, and location. You have a different formats are available. One is a numeric, another one is a alphanumeric or string character, another one is also numeric, and this is also a string like that. So it is a collection of all rows and columns with the different data items. So NumPy is having a collection of similar data items. That is, you have a homogeneous data, we can say. So these are all the things, some comparison I have mentioned. That's it. Okay, see here in the logistic regression analysis, in one why we are just taking as a logistic regression model or logistic regression analysis. So you have a different people are there, some Sam, Bob, or Matt. 3 people are there with the different age groups, and their different salaries also there. Suppose if you want to find out the average salary of age between 35 to 50, a person is having, Bob is having 35 and Matt is having 50. So you have to find some kind of average between the salary of these 2 people. In that situation, we are going for the logistic regression. Similarly, for the ages also, we can take it some total number of average salary of the respective ages. In terms of ages, in between you have some kind of analysis, and between the respective ages also and salary wise also you can go with the logistic regression. Okay, so this is a logistic regression model. Just I'm giving a brief thing, not more than that. It's a very basic model I'm giving. So you have a different parameters you are giving. The in the images I can you can see that you have a different parameters x1, x2, x3, like q1, q2, q3. You are giving some logistic regression model, you are applying it, and finally the outcome, already I have told that the output may be either 0 or 1. Here it is a happy or sad. So that is our thing. So logistic regression model as a part of the family supervised learning model. We know the parameters, supervisor and unsupervised. Unsupervised means you don't see any kind of data and any kind of patterns or relationships. But supervised, you know that which are all the data is coming from and where it is, what is the outcome of that. So you can have some kind of clarity and vision in the supervised learning data. So this is the logistic regression model. In a fine tuning, I am doing in a deeper way, that is predicting a disease risk. Disease risk. In this particular scenario, we are taking as a heart attack. We are predicting the heart attack in the early ages. So that is predicting we are making. So predicting disease risk, we can take it as a disease risk is a logistic regression model. We can go for it. Predicting voter behavior. Recently, we have finished our that election. So we just in that particular region. So which are all the voters have voted in some kind of party? We can say some kind of prediction. We can make it like that. Predicting product purchases depends upon the region. A person is a person is buying some kind of products. take some Trichy, Madurai or Chennai, what kind of product they are going to buy. A person who is having some kind of salary in between, a person is going to get what kind of product he is going to buy in a period of time like that. And predicting film preferences. So suppose a person between 25 to 30 is going to watch the movies. So what kind of film he is going to see, like that, the age groups, like. So that this is a model which is you will give some kind of analysis. So okay. So steps for building a logistic regression model. Create a model instance of the logistic regression class and specify hyperparameters with all possible values. Define performance evaluation metrics. Apply cross validation. Train the model using the training data set. Determine the best values for the hyperparameters given. So these are all some of the steps. The logistic function, there are 4-5 types. So in this particular logistic regression model, we have done some kind of these 5 steps for predicting the ages, predicting the earlier, that is predicting the heart attack between the early age groups. That is our focus, right? So we have a logistic function. Logistic function, I have already mentioned that between the value of 0 and 1, that means a person is getting heart attack 0 or 1. So then cost function. See, why we need to go for the cost function? Suppose when you are training the model, so you are doing some kind of analysis. Sometimes you will get some kind of loss while doing some training. Anyway, I will give it in a different way in the next slide. In an image way I can give, so that you will understand. This is we are doing in a data set based upon the data set value, but in the images I will give why we have to go for this cost function and why we have to take the gradient descent and prediction and put it all together. So anyway, I will explain in the next slide. So cost function, suppose when you are training some kind of model, you cannot give some kind of accurate result. Sometimes it may be you are giving a prediction may be he may get a heart attack in some kind of percentage, you can say percentage of accuracy, you can say. Suppose a person is getting a heart attack is 80% of accuracy, we can say. We cannot give 100% assurance, right? In all the model you cannot give 100% assurance. So like kind of accuracy you have to make it. Similarly for the gradient descent, this is for divided by weight. Anyway, you just take it as a blank. This is very mathematical calculation. I don't want to get into deeper, but while doing some execution part, you will come to know. Okay, so here we are going to predict a person is getting a heart attack or not, right? So here take some example, some image example. What I am going to do, I am going to train the dog images. A system, I am taking you are taking a system, you are going to train the images, that is dog images. I am training. First step 1, I am training the different kind of dog images. In the left hand side you can see one kind of dog images, the right hand side you can have other kind of dog images. So these two dog images are different. Okay, so we are training it, and suddenly you are training, suppose say some 1,000 dog images you are training, different 1,000 dog images you are training. After that, one point of time you are training a cat image. At the time the system will tell that this cat is also dog, or it will say it has some kind of error. So in that such case, so you are training different dog images, in between you are training some cat images. The system has to tell that this particular image is cat. It should not say dog. So that kind of analysis, that kind of training you have to make. Okay, next, see, in the gradient descent, so you are training more images one after the other. Suppose you are training some 5,000 images, that is not at all enough. You are training some 10,000 images, that is not at all enough. Maximum kind of images you have to train. See, first left different dog image, the next one is different dog, this is different dog image with one person is standing behind. and this dog image is different with a different, that background is different. So those things, all things you have to be taken care. So this is gradient, this is iterative procedure. You are training, keep on training, right? So why we are training? We are minimizing the error rate. So until your system has to tell, if you give any dog images, that system has to tell this is a dog image, right? So that kind of, you have to minimize the error rate. That is your step 3. Then finally, prediction, either after keep on you are doing some iterative process or iterative procedure, the finally the system has to tell, if you give any dog images, it has to tell it is a dog. If you give any cat image, it has to tell as a cat. So that is our objective. Okay. Okay, fine. Now I'll stop share. Okay, Jiva, do you and one person is also joined, Catherine. Okay, Jiva, do you have any questions till now?
No, sir. I will understand.
You understood everything, right?
Yes,
What
sir.
about the other one? Catherine also is joined. Catherine, which college you are from? Okay, fine. Now I will go to that. Okay, fine. Jiva, are you able to view my screen or not? One second. I will share it. Okay, now are you able to view?
Yes, sir. Visible.
Okay, fine. So this particular data set I am going to run in Google Colab. I think you might have seen that Google Colab. Suppose if you don't have, you just go to type and Colab. You just log in as usual. You are with your Google account. So just go to that, and you have to say some a new notebook, and you have to run as what we do for other things, right, in the Python code. Okay, first of all, before getting into these things, so I am already, we have discussed about the pandas and NumPy. So what we have to do, I think I will zoom it a little bit. So I am just importing NumPy, I'm importing pandas, and Matplot Live is for running the, when you are doing some kind of graph or analysis, you will use it for that. These two things. When you do some plotting or some kind of images, plotting your bar graph or some kind of graph related things, you are going for this particular, you have to import these libraries. So these are all the libraries you have to, that is a very basic thing. And I will show the one second, I will show that this data set also, you will come to know. Okay, so the data set I have already told you, no. So this is the age, sex and CP and rest with cholesterol and phosphorylating square and the resting, and these are all the values which is available. We have some kind of data set is available around. I think you have some thousand rows, right? So what we are going to do here, just I am just uploading, this is a data set. So just here you have to upload. I have already uploaded with this mounted. So first thing, I am executing the first one. It is executed. It will show the right tick, that is green tick, for successfully execution. Then you have to mount. It is already mounted. That is also, that part is also done. Yes. Now we are going to load, just seeing, displaying the data set. For that you need data or df, you can say. This is pandas. You have to read the CSV file, because we are doing a we are doing analysis in the CSV format, comma separated files. So where it is located, just I have given the path of the data set. So this is the path. So just we'll see that. Okay, this is the data set. Just I will show the, see the data sets. Already I have shown the data set, right? So just displaying it is just displaying it. First of all, we are just loading the data set and displaying it. Displaying head of 10 is nothing but the 10 records I am displaying it. Okay. Okay, fine. Next one is data overview. So we have to, a data set can have a different kind of data types. I think you might have seen different kind of data types are available. Just I want to know the data types, that just print a data set shape, data dot shape. Automatically it will give that shape as well as the info. Just I'm running the data, what kind of data is having. So these are all the age is having, some data type is integer. So here old peak is float, like that. So this is a data type. To know the data type, what kind of data is available in the data set. Okay. Next, checking the missing value. So suppose in this 1,000 rows, you may have values, zero values. That means the data may not be recorded. A person is not having any kind of, the value is null. Just we want to know. So that just I am summing here. A data that is a row is having some kind of null value. Just we are checking for missing values. Some of the missing values. Okay, there is no missing value here. So then here, so here that we are going to target, just we are going to display a target. So in the data set here, see the target is a person is having a, if a person is having a 0 or 1, a person is 1, if a person is having value is 1, that means a person is getting heart attack. If it is 0, like that, some kind of analysis here. See, this is target, we are just counting the value of that, and we are going to make some kind of that plot side, that is figure, bar chart we are going to make it here. So this is hard presence is here. 0 means 0, 0 means no, 1 means yes. A person is having a 0 means there is no heart attack, 1 means there is yes. There are two values we are going to make, right? Just I am going to run this. I think it is all are understandable and easily it is self-explanatory, I think so. So heart disease, a person is having, if it is 1 means a person is having a heart attack, and 0 means there is no heart attack. Just it's a bar graph. Okay. Okay, the next one is splitting the data set into the features. See, in the data set, how we are going to train the model. So normally in 80 percentage in the data set, in any data set, it may be an image data set, it may be an ordinary numerical value data set. Normally people will be training 80 percentage of the data set is a training model, and 20 percentage will be a testing model. So that kind of split we will make it like that. They are making some kind of split. See, splitting the data set here. One second. Just we are splitting and dropping it. Okay. So here, train the split. We are just splitting here, and we are training the split. We will see the output. See, just we are splitting here. That means 0 values we are splitting here. So to count, okay. So here, just the next one, we are counting how many people having some kind of male or female, how the count of the number of people. We are just going each column by column. See, just we are going some analysis. See, one is having 713, and just we are saying that one is a male and female, right? And next one is age distribution. So I am running, understand, I am running each and every column with the different distributions. To know the deeper analysis, I am running each and every column here. Just this is age with histogram. See this particular histogram analysis. See majority of, see in this majority of that 50 to 60, or we can say 55 to 65 is having some kind of distribution. These are all are very we can say in a danger zone, right? I think normally if you have a older ages, you will get a problem, more problems. Okay, so here that we have talked about the resting blood pressure, right? So here I am running with a different histogram equalization. See here also between 130 to 150, or here 175 in this frequency. In this frequency we are getting more kind of, so a person is having between these values is there is a possibility of getting a heart attack. So that values around 175, that is 150 to 175 we can say. If you get those kind of values, a person is getting some kind of heart attack. So that is our prediction. So we are having a three so then the topic itself, I have clearly mentioned that 360 exploration of data insights. That's the reason I am doing each and every column and with particular graph. Okay, next one. Similarly, for this is also one of the values. You can all, anyway I will go quickly. This is also having some kind of, see, maximum heart rate distribution. If you have 120, more than 120, definitely there is a possibility. Okay, number of major vessels. This is also one of the important aspects, important factor. Major vessels distribution. Many of them is having some kind of vessels problem. Maybe during that some kind of block will be there. If you have a multiple blocks, you have some kind of vessels problem or something like that. Anyway, I'll run it here. Here also. See, number of major vessels distribution. This is also value is higher value, you will get that. So in this particular thing, they have given a 4 category. 4 vessels value, that is chest pain type we have talked, right? You have a 0, 1, 2, 3. So these are all the values are there. Between these two means 0. These two means 1. These two means 2. Like that. These are all different categories. Different vessels type. Okay. The next one, age versus maximum heart rate. This is also just a comparison between the age and the heart rate. It is a distribution. So in the ages, can you see that in this 50 to 60 years, you will get more kind of, see, maximum heart rate is 172. When you see 54, 167, it is huge. When you take some 43 in 177, these are all some of the things. But here, majority is 50 to maximum is 50 to 65, we can say, in this particular region. Age versus maximum rate, heart rate. This is for chest pain type. There are 4 types. We have already talked about that. Yes, there is 0 to 0, 1, 2, 3. With the different values, you will get chest pain type. We are just giving the info, and we are removing the duplicates. Suppose if you don't have values, just removing the duplicates. Just this is just showing the total values. Okay, see here what we are doing some analysis. We have already talked about the analysis, right? We are going to find out the deeper insights. Here there are 2 categories. One is for numerical value, another one is for the category value. So numerical, they have divided, see that they have divided Numerical value is age, trust BPS, cholesterol, and thalach, one world peak. In the category you have, these are all the sex and chest spine type, flood, what is that, ASB. These are all the category. Suppose the category means a person is having some kind of fasting blood sugar is having some kind of value. A person is having some kind of problem. A person is having rest CECG some value. A person is having some kind of loss. So that is a categorical. This is a numerical. There are two things they have divided. Okay. I think there is some error here. One second. Yeah, I'm running this. Okay, fine. See, see here, just they are going to see the statistical analysis here. See, totally what is the count of that particular age and mean, standard deviation. These are all some of the statistical analysis. When you do any kind of AI model or some kind of prediction mechanism, we will go with the some kind of statistical analysis. See, some 25 percentage of this particular value, 50 percentage of this value, 75 percentage of this value, and max. So this is a mean, standard deviation, and minimum, like that, right? Statistical analysis, definitely they will make it like this. Next, categorical. Okay, so I am making here some kind of different uh, histogram, the different bar thing. See, first one is sex, second one is CP and FBS rest. So they have divided in a different category. One is a 0, another one is a 1. Already we have told, right? If it is 0 means there is no heart attack, 1 means heart attack, like that. So we have divided in the two different categories. Next, numerical analysis. So this is one kind of analysis, numerical analysis with a different bar graph. So here, just I am giving a brief thing. So already we have discussed about the training model and testing model. I have told you. So training means we are just training the images, or we are just training the data set. 80% of we will train and 20% we will go for the testing thing. So here they have taken a upper bound and the lower bound. Why we have to take a upper bound? So you should have some kind of suppose the value may be when you see for example in a diabetes, a person, if a normal person has to have fasting blood sugar level between 70 to 120. So 120 is the maximum. If you go beyond 120, definitely a person is having diabetes. So that is the conclusion. So like that, you have to make some kind of maximum value and the minimum value. Between this value, if you cross or if it overcome that value, definitely a person has some kind of abnormality in his health. We have to take care. You have to go and see the doctor if you have any kind of different values. Okay, so that kind of here. So here is, you have to first of all define the minimum value and the maximum value. So just here I am running this. See, just a outlier means value is if you cross that particular value, that we are saying it is the outlier. Already I have discussed in the images. I told you, no, if you train the dog images, suppose if you are putting some kind of cat images, the system has to tell. Otherwise, there is some error rate, some kind of error rate you will get. So now we are going to make some kind of data model here. Just So this is the data model. See, true or false, just it's making either true or false. So checking a distribution, so how many zeros and how many ones. It is showing that 128 125 0 and 158 is 1. See, this is our model. A person is heart disease is that is orange or red color. Zero means it's green color. That means a person is not having the heart attack. In this particular value, this person is having a heart attack, like that. Okay. So here, developing the first model. This is based upon the values, based upon the data set. We are just making out of it using some kind of statistical analysis. We have told that if it is a 0 or 1, just predicting the value. This is the model algorithm. Already I have told you, we have to divide. One second. We have to divide. We are just calling a logistic regression model here, and just we are dividing. Yes, it's running, and that we are training the model and we are going to predict it. Okay, so finally it will show the. Okay, so finally I will tell you how it has come. See, basically, in any statistical analysis, what we will do in this particular logistic regression model also, I have told you, either it will fall under 0 or it will fall under 1. In between values, you will get different kind of numerical values you will get. So, in any statistical analysis, people will say a method called confusion matrix. Normally, it is a 2 by 2 matrix. Anyway, I will show you in Paint. See, normally in any uh, so normally people will say this is a confusion matrix. Here it is 0, here it is 0. Normally it will be like that: 0 0 0 1. I think you might have aware of this: 1 0 and 1 1. In other words, people will say this is true false. Here also true false normally. So here true true, people will say this is true true, true false, sorry, false true, and false false. In any statistical analysis, people will come to this as a conclusion. Normally they will say this is a true positive or true negative, or true positive or true TP, that is true positive, uh, true negative, or false positive or false negative, like that people will say. So this is the idea. Normally in any confusion matrix, any statistical analysis, people will say with this conclusion. Same thing here, we did it for that. So the confusion matrix we have done, we have made some kind of values. So here it is saying a green and red green. So red means what? A person definitely is having a heart attack. Green means a person doesn't have the heart attack. So that those two values only we are making it. And finally this value. So after a long logistic regression model, we are just coming into the conclusion that a person is having a heart attack or not. So if you have a person is having the target value is 1, means a person is having a heart attack. A target value is 0, a person is not having the heart attack. Similarly, as per the numerical category, you have to go with the analysis of different kinds of values which is given in the data set. Based upon the data set values, we are predicting a person is having a heart attack or not at the early stages. So that's it. Any doubts, Jiva? or Catherine and Sarubala Balakrishna. I think you got some kind of basic idea about that, why we are going for this particular model. Okay, any questions from the audience? This is very, very basic model. I have explained it. Money, you can stop the recording again.